Just tell me, is my screen visible?
Ma'am, I didn't get yesterday's notes.
Yes, Safrina.
I didn't get yesterday's notes.
Okay, I will share the notes after today's class. Okay, I will share the combined notes, yesterday notes and today's class. Okay, so okay, is this question clear to you? I think I have already discussed that, how you will write down the reagent and how you will cleave the bond. Okay, so the next question is ditert butyl ether cannot be prepared by Williamson ether synthesis. Why? Ditert butyl ether. First, draw the structure of ditert butyl ether. So tertiary butyl. So this is the ether linkage. Okay, and both the side, there is a tertiary butyl group. Tertiary butyl group means this group. CH3, CH3, CH. Carbon, CH3, CH3, and this is CH. So this is your bi-tertiary butyl ether. Question is, why we cannot prepare this ditert butyl ether by Williamson ether synthesis? Do you know the answer?
Because um
Yes, just try it.
because both the CH the alkyl groups are similar. It should be
Similar, but it's tertiary one. You can see this is oxygen linkage, and this group both are tertiary groups. So this this ditert butyl ether must be formed by the reaction of tertiary haloalkane and the tertiary alkoxide, sodium alkoxide. And you know very well, in the tertiary structure, there are more methyl group. This methyl group, it hinders. Okay, it basically hinders, and it does not react or does not show the nucleophilic substitution reaction. Because you know very well, this occurs via substitution reaction. Yeah, just a second. Now see, this is a group and this is another group. Okay, so when you cleave the bond, we will get to know that this must be formed by this when you break this bond, carbon and oxygen bond. इससे आप क्या बनाओगे? This structure से you will form the alkoxide. Okay, sodium alkoxide. So here this ONA, O plus Na, and there are three methyl groups. Due to the three methyl group, there will be more hindrance because these methyl groups are very bulky. There will be more hindrance. Plus, this one, this will form, CH3 carbon, and here you can add any halogen. Okay, I'm just putting bromine over there. Methyl, methyl group, and methyl. So this tertiary butyl ether must be formed by the reaction of these two. These two. This is your alkoxide, tertiary alkoxide plus your tertiary haloalkane. Haloalkane. And you know very well, we prefer primary haloalkane. We prefer primary haloalkanes because In the primary haloalkanes, there is no bulky group. Bulky group present नहीं होता, and in the tertiary and in the secondary one, there are more bulky group, this methyl group, which hinders the reaction, and due to that, the substitution reaction doesn't occur. Okay, instead of substitution reaction, elimination occurs. Elimination reaction हो जाता है. So due to that, we don't prefer tertiary and secondary haloalkanes. We only prefer primary one. Okay, because we have already discussed that. See this point. To form to form unsymmetrical type of ether. Okay, or for the same symmetrical type of ether के लिए भी primary alkyl halide should be used preferably. Primary alkyl halide. Okay, and if you use the secondary and tertiary haloalkane, it will lead to the formation of alkene as they are more hindered. Because there are more bulky group like CH3. You can see there are three CH3 group over there, three CH3 group. और CH3 group क्या होता है? These are plus I group. Plus inductive effect ये show करता है. Okay, it just shows plus inductive effect. Now the question is, what is inductive effect? So this plus inductive effect, it is basically due to this methyl group, it pushes the electron density towards the carbon, towards the carbon. Okay, and this methyl group, again, this is plus I. All the alkyl groups are plus. They show plus I effect, plus inductive effect. So they just push the electron density towards this carbon. Okay, towards this carbon, and due to that, the electron density on the carbon increases. So इस पे carbon पे आ जाएगा negative charge, partial negative charge. And this bromine, because you know very well, bromine is more electronegative, more electronegative. So that's why it's ये भी electronegative है, and due to the more inductive I plus I group, the carbon will be electronegative. Okay, will acquire partial negative charge. So due to that bulky group, it hinders the reaction. यहाँ पे nucleophilic substitution reaction won't take place. Instead of elimination reaction takes place, and you will not get the desired product. You will not get the ether. You will get the ether plus your alkene, right? You will get the mixture. So that's why di-tertiary butyl ether cannot be prepared by Williamson ether synthesis. Okay, because it must be. So you can write down this one. This is the point. This is the reason. This requires the reaction of tertiary haloalkenes with tertiary alkoxide, which results in the formation of alkene. Because you know very well, when you use secondary or tertiary haloalkane, then there will be more hydration. Okay, this methyl group, the methyl group, more will be the hydration, and more will be the hydration, there is a chance of elimination reaction instead of nucleophilic substitution reaction. So instead of nucleophilic substitution reaction, यहाँ पे क्या होता है? Elimination reaction. And if elimination occurs, then it will lead to the formation of alkene, not the ether. So that's why we can't use this Williamson ether synthesis to prepare di-tertiary butyl ether. That's the reason. Got my point, Safrina? Any doubt?
Mm.
Okay, let's try down. Done?
Yes.
Okay. Okay. Can you tell me, Safrina, can we prepare this diaryl ether by using Williamson ether synthesis?
No.
Why? What is the reason?
Mm.
This is a diaryl ether. On both the sides, there's a aryl ring, benzene ring. So is it possible to prepare this product using Williamson ether synthesis? Just think about it. It's very easy. I explained you in the previous class. See, this is a benzene ring. This is oxygen linkage. You can see this oxygen is involved in the resonance with the benzene ring. So is it possible to break this bond? No. No, there is a partial double bond character between both the aryl ring. Okay, you can see this oxygen is involved in the resonance with this benzene ring. So there will be a partial double bond character between this carbon and the oxygen. And same over here. Okay, there will be a partial double bond character between this carbon of the benzene ring and the oxygen. So that's why, due to the partial double bond character, this is very difficult to break. So we can't prepare this diphenyl ether using Williamson ether synthesis. Got it?
Due to the partial double bond.
Yeah,
Yeah.
due to the partial double bond character. Okay, so you can write on the reason. Another reason you can write. So this requires basically ये reaction. This is the product. ये product कैसे बना होगा? What must be the reactants? So reactant must be your phenoxide. Okay, this phenoxide and with the haloarenes. So if you suppose if this bond will break, so you will attach the halogen atom over there. So this will be one benzene ring. It will form the haloarene, and the second one, this benzene ring with this oxygen. So you will attach Na over here. So if you prepare this using Williamson ether synthesis, so what must be the reactant? So reactant should be the phenoxide, sodium phenoxide, plus the haloarenes. And you know very well, Williamson ether synthesis क्या होता है? This undergoes via nucleophilic substitution reaction. And haloarenes don't show nucleophilic substitution reaction. Haloarenes don't show nucleophilic substitution reaction. So that's why you can't prepare this product using Williamson ether synthesis. So you can write down the reason. This requires the reaction of phenoxide, phenoxide with haloarene, with haloarenes. But haloarene, haloarene don't show nucleophilic substitution reaction due to partial double bond character. Due to partial double bond character of carbon of the benzene ring and CX.
Done.
Okay. So that's the chemical properties of ether. Method of preparation of ether. Now the physical properties of ether. Okay, now see what is ether. So ether is ROR. General representation is ROR. So you can see there is oxygen between the two alkyl. Okay, and oxygen has a lone pair. So this is slightly polar. This is ether is slightly polar in nature. Okay, and ethers have, just remember this, ethers have lower boiling point than alcohol. Alcohol से lower boiling point होता है. Why? Due to the absence of hydrogen bond in ether. So in itself, in ether, the hydrogen bond is absent, and you know very well, alcohols में क्या होता है? There is a hydrogen bonding. Hydrogen bonding is present, and hydrogen bonding is quite strong as compared to this ether. Okay, so hydrogen bonding is very much strong. So due to that, due to the more force of attraction in the alcohol, the alcohol has high boiling point. Okay, as compared to the ethers. So, but ether have lower boiling point. Why it has lower boiling point when you compare to the alcohol? Due to the absence of hydrogen bond. Due to the absence of hydrogen bonding. And the boiling point of ethers is slightly higher than hydrocarbon. Normal hydrocarbon chain जो होता है like your alkene, alkene and thing. So it is compared to the hydrocarbon chain with a similar molar mass. Okay, if the ether and the hydrocarbon both are similar, okay, number of carbon is same and the molar mass of both the molecule is same, then the ether is slightly higher. The boiling point of ether is slightly higher than the hydrocarbon when you compare these two. Next point, ethers are soluble in water. Now see, they in itself, in itself, ether has no hydrogen bonding, but it can when you add water. Suppose you take the ether, okay, आपने ether लिया और water में add कर दिया. Okay, you are just trying to solubilize in the water. Ethers are soluble in water because they can form hydrogen bond with water. Water के साथ वो hydrogen bond बना लेते हैं. So that's why ethers are soluble in water. Now see how they are soluble. You know very well, hydrogen, this water, H2O, this is your water. And you know very well, hydrogen bonding के लिए क्या important होता है? Hydrogen का presence होना. So this is in water, hydrogen is present, and hydrogen is it is very important to hydrogen is attached to the electronegative element, most electronegative element. So like your fluorine, oxygen, or nitrogen, इनसे attach होना चाहिए hydrogen. Okay, so what is the criteria or conditions, terms and conditions for the hydrogen bonding? First one is your hydrogen should be present. Okay, and hydrogen किससे attach होना चाहिए? To the most electronegative element. Okay, so here in water you can see hydrogen is present and hydrogen is attached to the oxygen. So there will be a polarization. यहाँ पे क्या होगा? Dipole moments होंगे, polarization होगा, there will be a difference. You can see there is a large difference in the electronegativity. Okay, oxygen is more electronegative and hydrogen is electropositive. So oxygen will acquire partial negative charge and this hydrogen will acquire partial positive charge. So that's water. So that is water. Now, when you add ether into the water, what happens? Suppose you just take ether, ROR group. This is your ether. And you know very well, oxygen पे क्या है? There's a lone pair, right? So this hydrogen, this water के पास जो hydrogen है, this hydrogen has a partial positive character, positive charge on it. So it will try to make hydrogen bond with the electronegative element, which is oxygen. So it just make the hydrogen bond with this oxygen of the ether. Okay, similar. So similarly, suppose another ether come, like, okay, and here there will be a partial positive charge and there will be partial negative charge. Again, this hydrogen will try to make bond with this oxygen. Okay, because it is more electronegative. तो ये क्या करेगा? इसे attract कर लेगा. So that's how ethers are soluble in water. Why it is soluble? Because they can form hydrogen bond with water. Clear? Due to the presence of oxygen which has a lone pair. Now, see this. This is very important. Increase in the number of carbon atom will decrease the solubility. Now, more the, suppose this is your alkyl R group. Suppose R group है आपका CH3O CH3. Okay. So if they will give you a question, just arrange in order of increasing solubility, and they will give you this ether CH3O CH3. Second आपको दे दिया CH3 CH2O CH3 CH3, right, this one. Okay, diethyl ether, this is dimethyl ether. Third one, suppose they just give you dipropyl ether, CH3 CH2 CH2 oxygen CH2 CH2 CH3. Okay, and they will and the question here is arrange these in order of increasing solubility. Okay, now the trick is, see this point is very important. Number of carbon atom is inversely proportional to the solubility. Okay, if you increase the number of carbon atom, the more the bulky group, it will hinder the solubility. Zyada bulky group hoga, it will hinder the solubility, right? So you will arrange, how you will arrange this in increasing order of the solubility. So A will have the more solubility, higher solubility, because the number of carbon is less. If the number of carbon is less, it will be more soluble because they have inverse relationship with each other. Number of carbon atom in ether is inversely proportional to solubility. More the number of carbon atom, less will be solubility. Okay, and vice versa. So in these three, A, B, and C, which one will have the highest solubility in water? Which one is more soluble in water?
Mm.
A, right?
A,
After A,
mm,
A, after A, B,
B,
right? Then C. Okay, because
C.
number of carbon, if in the B molecule, the number of carbon is 2, 1, 2, 3, 4, right? And here, more the number of carbon, so less will be the solubility. So that's the order of solubility. So that's the physical properties. These are some points you should remember. This is important. Okay. If you want to write, just write it down quickly.
Done.
Okay, done. Okay. So write down the next heading. Next topic is chemical properties of ethers. Chemical properties of ether. So first property and first reaction we will discuss, in which we will see the cleavage of CO bond. Okay, CO bond, carbon and oxygen bond ko we will cleave. So first reaction is reaction with HX, your halogen acid, your halogen acids, HX. Okay, so what we do in the reaction with HX, when the treatment of ethers with HX, halogen acids, they leads to the formation of corresponding alcohol plus haloalkene. When you react ether with HX, any halogen acid like HCl, HBr, HI, anything, so it will lead to the formation of alcohol plus haloalkene. Okay, now let's see the general reaction. Suppose we have ROR. This is your ether, and we are just treating this ether with the HX. Okay, so this oxygen has a lone pair, right? Now this HX, halogen acid, it will dissociate to form H plus and X minus ion. Okay, because halogen is electronegative, so X minus and H will get positive charge. Okay, now this H positive, so this oxygen which has a lone pair of electron, it will approach hydrogen. So hydrogen को approach करें. So basically you can show like this, the hydrogen over here and the X over here. Okay, so basically you have to cleave the CO bond. CO bond. If there is a symmetrical type of, if it is a symmetrical type of ether, so you can cleave any bond, any CO bond. This C or O bond or this on the right side, any bond. So what happens over there? This bond will break, this bond will cleave, and this oxygen has a lone pair. It has a negatively charged ion, right? ये lone pair क्या है? This is negative electron. So this H plus, this will abstract this H plus. Okay, so ये H के साथ ये bond बना लेगा, and this R will break, will attach with the X, because R will get positive. Like so, this will between this bond between this oxygen and alkyl group. Oxygen is electronegative, right? So this will acquire partial negative charge, and this alkyl group will acquire partial positive charge. So this partial positive charge के पास क्या आएगा? X, halogen atom, right? So it will come, halogen atom will come and make bond with the R group, alkyl group. And this oxygen, ये किसके साथ bond बना लेगा? Your H plus ion के साथ, because it has a partial negative charge on it. And what happens? This bond will cleave. You are supposed to cleave this bond. So what happens when you cleave this bond? क्या क्या बनेगा आपके पास? So this ROH, this alcohol will be formed plus your RH will be formed. So your product is ROH plus your RX. So when you treat the ether with any HX, any halogen acids, so this bond will cleave, OR bond, O carbon and oxygen bond, because alkyl group has carbon. So this carbon and oxygen bond को आपने cleave कराना है, right? And between this oxygen and alkyl group, this oxygen is more electronegative, so it will acquire partial negative charge, and this carbon will acquire partial positive charge. Okay, and you know very well the opposite attract each other. ये oxygen is electronegative, it has a partial negative charge, so it will try to make the bond with the hydrogen atom because it is positive, H plus ion. Okay, and this R group के पास क्या आएगा? X, halogen atom, because it is electronegative, X minus. Okay, so that's how they will make the bond, and the product is ROH and RX. यहाँ से bond cleave हो जाएगा and you will get two products, alcohol plus your halogen. Is it clear, Safrina? Okay, you are supposed to cleave the carbon and oxygen bond, any CO bond. आप ऐसे भी कर सकते हो, just like this. If it is a symmetrical type of ether, if it is symmetrical type, so you can cleave any bond. You can cleave any bond. Suppose this oxygen and this R. Okay, on the left side, this R. So between this oxygen is electronegative and this is electropositive, right? And this H plus and X minus. It will dissociate to form H plus and X minus. The oxygen will make bond with the hydrogen. Okay, and this alkyl group will make bond with the halogen. And what happens from here? This bond will cleave. Okay, three steps आपने करना है. This bond will cleave and you will get this ROH, alcohol, plus your RX, plus your haloalkane. So these are the two products. Clear? Okay. So in this reaction with HX, first one is your with symmetrical ether. So again, we will study two things. What will happen if there is a symmetrical ether and which trick we will apply when there is an unsymmetrical ether. Okay, in the unsymmetrical ether हम क्या apply करेंगे, and in the symmetrical one it is very simple. It is very simple. You can cleave any bond, any CO bond, because both are symmetrical. Both are symmetrical, so you can cleave any CO bond. So in the first question, say this. So this is the hydrogen. Okay, I'm just using this oxygen and CH3. Okay, both are same. This is a symmetrical type, so you can cleave any bond. So just H plus and I minus. So H will come and it will make bond with this oxygen, and this iodine will come and it will make bond with the CH3. CH3 because iodine क्या होगा? It is negative. This is negative H plus. This is it will dissociate from H plus and I minus. And similarly, oxygen will have partial negative charge. It will have partial positive charge. So partial positive के साथ iodine will come and attach because iodine is electronegative. It has a negative charge on it. So it will try to make bond with this. And oxygen के साथ क्या होगा? Hydrogen. And from here, this bond will cleave. This bond will cleave. So what you get when this bond will cleave? CH3OH. You will get methanol, CH3OH, plus your CH3I, methyl iodide, CH3I. Okay, so you will get alcohol plus your corresponding haloalkane. Clear, Safrina? 100%?
Yes.
Okay, do the rest of the question. Second and third. Follow the same mechanism. Write down in your
CH3,
notebook. Yeah, CH3,
CH2OH
CH2OH. Very good.
plus CH3, CH2Br.
Okay, so hydrogen will come over here. Okay, and from here the bond will cleave. And इससे क्या होगा? This carbon से hydrobromine will attach. So you will get CH3, CH2Br. Okay, and here you will get CH3, CH2OH. Okay, similarly, do the same thing. HI, iodine. Okay, again it's a symmetrical type, so hydrogen will come and attach to the oxygen, and from here the bond will cleave. And आपने कहाँ पे attach करना iodine? This. From where the bond will cleave. So this is a carbon. You have to attach the iodine here. So what you get? You will get this one. 1, 2, 3 isopropyl alcohol plus your 1, 2, 3. So you can see on the second carbon, if you start the numbering 1, 2, 3, on the second carbon there is attachment. So you can just keep like this. So these are the two your products. Isopropyl alcohol and your isopropyl iodide. Clear? So symmetrical one is clear. Now it's an unsymmetrical ether. Now the question is how we can which bond we will cleave. Okay, because we have to cleave the carbon and oxygen bond. But in the unsymmetrical type of ether, both the groups are different. Okay, so how you will cleave the bond, which bond you will cleave. Okay, so see over here. In the unsymmetrical ether, what you're supposed to do, first thing, always when you see the unsymmetrical type of ether, और आपको reagent क्या दे रखा है, halogen acids, any halogen acids, HBr, HCl, anything, and you have to write basically write on the product. What will be the product? Question mark. So first step is check if there is any tertiary alpha carbon or not. If there is any tertiary alpha carbon or not. If there is any tertiary alpha carbon, then attach the halogen to that carbon. Okay, attach करना है halogen को tertiary alpha carbon से, and the remaining fragment will form the alcohol. Will form the alcohol, because this is again the reaction with the halogen acids, and you know very well the treatment of ether with the halogen acid will form alcohol plus your haloalkane. तो आपने यही दोनों चीजें बनानी है, alcohols plus haloalkane. But the question is which group you will use to form the alcohol and which group will form the haloalkane. Okay, here the first step क्या होगा? First step will be you have to check whether there is a tertiary alpha carbon or not. Okay, so this is oxygen ethyl linkage. So here this is the alpha carbon. Suppose this is alpha 1. This is your alpha 1. And suppose this is your alpha 2 carbon. So there are two alpha positions, alpha 1 and alpha 2. Now check which alpha carbon is tertiary. Tertiary alpha carbon present hai ya nahi. Now just check it and tell me which one is a tertiary alpha carbon. Yes, alpha 2 is the tertiary. So this is the tertiary alpha carbon and this is the primary. Okay, this is the primary alpha carbon. Second step, attach the halogen atom, this halogen Br, bromine to the tertiary alpha carbon. Okay, so you will cleave this bond. You will cleave this bond. So first step, you will check whether the tertiary alpha carbon is present or not. If tertiary alpha carbon is present, then attach the halogen atom to that alpha carbon. Tertiary alpha carbons attached. So you will get this product. 1, 2, 3, and there you will attach the bromine. Plus the remaining fragment. This is the remaining fragment. Okay, this CH3, CH2 and this oxygen. This remaining fragment will form the alcohol. Okay, so आप इससे attach करोगे hydrogen. You will attach the hydrogen to this oxygen and you will get ethanol over there. You will get ethanol. Is it clear? Okay, do the second one.
CH3, CH2, CH2OH plus.
Yes, this will form. So this is your this oxygen. This is your alpha 1. So this is your tertiary 1. Okay, this is your tertiary alpha carbon and this is your primary alpha carbon. So this tertiary one, from here you will break the bond. From here you will break the bond and tertiary alpha carbon see you will attach the halogen atom. So it will form CH2, CH3, CH3 over here, CH3, and to this carbon, to tertiary alpha carbon, you will attach the iodine. Plus, this will form haloalkane. Okay, now this remaining fragment, it will form CH3, CH2, CH2. Okay, so this will form propanol. Now let's understand the mechanism for this one. Okay, so first thing, because you are using the halogen acid, right? So this, suppose this HI, okay, I'm discussing this mechanism, first reaction mechanism, this one, the mechanism I discussed. Okay, so this HI, okay, suppose that we have HI, so it will dissociate to form H plus I minus, because iodine halogens are electronegative, so it will acquire negative charge and the H will acquire plus charge. So it will dissociate to form H plus I minus. Second step, the protonation of ether. The protonation of ether. So suppose we have this one, 2, tertiary. Okay, so this is a tertiary alpha carbon and this is your primary. So oxygen has a lone pair. Second step, oxygen has a lone pair and this H plus ion. First step में this H plus ion plus I minus. So this H plus ion, the H plus ion is present. So what happens? This oxygen has a lone pair. So it will abstract this hydrogen. यहाँ पे क्या होगा? There will be a protonation of this oxygen. Oxygen का यहाँ पे protonation होगा, right? Because there is a halogen acid. Okay, acid है and acid it contains H plus ion. So oxygen has a lone pair. It will abstract this H plus ion, and here you will get when it abstract this hydrogen proton from here, so it will acquire this. Okay, so again, this oxygen has a three bond, so it will acquire positive charge. Now this is quite unstable. This is very unstable. So what happens? यहाँ से ये bond break हो जाएगा. This bond will break from here, and this will shift over here, right? And in the third step, another basically when this bond will break here from here, when this bond, see this, यहाँ से ये bond break होगा, so it will form CH3 CH2OH alcohol, right? And when this bond will break from here, so it will form carbocation. It will form carbocation. यहाँ पे carbocation का formation हो, right? So what happens? This is alcohol. It will form alcohol CH3 CH2 and OH. OH plus this carbocation is here, right? Tertiary carbocation. 1, 2, 3. Okay, this is a carbocation, the formation of carbocation. Tertiary carbocation, you know very well, tertiary carbocation is very reactive. It's very reactive. Tertiary carbocation बहुत ही reactive होता है. And we have this H plus ion to consume हो गया. Now we have I minus. This I minus ion. So this carbocation is very reactive. When the I minus ion is present in the reaction, what happens? This I minus ion, it will come and attach over here, this carbocation, and you will get this isopropyl iodide. Okay, so you will get this one. So what is the product over here? Alcohol plus isopropyl iodide. That's the mechanism. First one is the dissociation of H plus ion. HI will dissociate to form H plus and I minus. Second step, we have a ether. We have a ether, so it will abstract oxygen. Ether के पास के oxygen, and oxygen has a lone pair. So it will abstract this hydrogen. Okay, acidic hydrogen को ये abstract कर लेगा, and there will be a protonation of this oxygen. Okay, once the protonation has been occurred, what happens? This point is quite unstable. So unstable है due to that, यहाँ से ये bond will cleave. This bond, carbon and oxygen bond will cleave from here, and you will get alcohol. So you will get alcohol, and once the bond is cleave over here, so it will form the carbocation. This will form carbocation, right? And when the carbocation is formed, because this is the tertiary carbocation, so this tertiary carbocation is reactive, very reactive, because you have I minus ion in your reaction. आपके पास reaction में I minus भी है, because H plus has been consumed over here. You have I minus, so this iodine will come, I minus ion will come and attract. Basically, it will attract this carbocation, this carbon, which has a positive charge on it. Okay, and you will get isopropyl iodide. So that's the whole mechanism. Is it clear, Safrina? Okay, just quickly write down by your own. Write down this reaction. Okay, and after that you can write down this mechanism.
Can you scroll down a bit?
Up.
Down now.
Okay, done.
Ma'am, last line. Done.
Done. Okay. Now the question is, now, yeah, we have seen those type of unsymmetrical ether in which tertiary alpha carbon is present. Now the question is, what if there is no tertiary alpha carbon? Okay, what if there is no tertiary alpha carbon in your ether? So what we are supposed to do? So if only primary and secondary alpha carbon is present in the ether, then you are supposed to choose less hindered halogen, less hindered alpha carbon. So less hindered alpha carbon will get the halogen. Okay, means they will form the haloalkane, and the rest of the fragment will form the alcohol. Because at last you have to prepare the alcohol plus your haloalkane. Okay, but what if there is no tertiary alpha carbon? Tertiary alpha carbon hota tha to we just attach the halogen atom to the tertiary alpha carbon. But what if there is only primary or secondary alpha carbon in your ether? In your ether, if there is only primary and secondary alpha carbon, so you will always choose the primary alpha carbon to form the haloalkane, to form the halogen. Basically, halogen will get attached to the less hindered alpha carbon. So between the primary and secondary alpha carbon, which one is less hindered? Primary one, right? So always choose the primary alpha carbon to form the haloalkane. So always you will prefer the primary alpha carbon. Okay, so let's see this example. So you can check over here. This is oxygen linkage. So there are two groups. This is your, so this is alpha one. This is your alpha carbon, which is one. Alpha one मैंने इसे name दे दिया. This is your alpha two. Now check which one is primary or which one is secondary. So this is your alpha one is primary, right? And this alpha two is secondary. This alpha two is secondary because it is further attached to the two groups CH2 over here and यहाँ पे CH3. So this is the secondary. You can check over here. This alpha 2 carbon is more hindered. It is more hindered because there are one methyl group over here and one CH2 group over here. So two heavy bulky groups are attached to this carbon. So which is more hindered as compared to the primary one. So you will choose this primary one to prepare the haloalkane. So this iodine will come and attach to this carbon. So it will form 1, 2, 1, 2 carbon, and here you will attach the iodine. So you will choose primary alpha carbon to form the haloalkane, and the rest of this uh, fragment will form the alcohol. Okay, up hydrogen. This is the H plus and I minus ion. So I minus will come and attach to this carbon. This carbon which is less hindered, alpha one carbon. Okay, and the rest of the fragment, so this will form the alcohol. So hydrogen will come and attach to this oxygen. So it will form 1, 2, and here there is a substitution and OH. So this is the product. Alcohol plus your haloalkane. Yes, Safrina?
Ma'am, for the last one, the uh, heavy group was for
The
halogens,
last
right?
one? Yes.
For the last one, the heavy groups bonded with the halogen, right?
No?
Like the tertiary.
Yeah. The tertiary, yeah, well, the tertiary one, that is the another trick. Whenever there is a tertiary, first आपको check करना है if there is an unsymmetrical type of alkene. So first step, always check for the tertiary alpha carbon. If the tertiary alpha carbon is present, then you have to attach the halogen to the tertiary one. Then you have to attach the halogen to the tertiary one, right? So you will prepare this one. Halogen आपने इससे बनाया, right? Tertiary haloalkane. But if there is no tertiary alpha carbon, if the tertiary alpha carbon is absent, means only primary alpha carbon and secondary alpha carbon, don't correlate these two things. Okay, don't correlate because you will confuse. So if tertiary, primary and secondary alpha carbon is present, then what you are supposed to do, then the alkyl group, which is less hindered, will get halogen. Will get halogen. So less hindered hoga will get halogen, and the rest fragment will form the alcohol in this case. Okay, don't be confused in this case. First, always, if there you will see the unsymmetrical type of ether. Say, first step, आप find करोगे whether a tertiary alpha carbon is present or not. If it is present, then it is very clear. Then attach the halogen to the tertiary alpha carbon. Okay, and the rest of the group will form the alcohol. Now here, if the tertiary alpha carbon is not present, say primary or secondary, then you will choose primary alcohol to prepare the haloalkane. Okay, okay, don't correlate that here वहां तो हमने tertiary को लिया था haloalkane prepare किया था, but here we are just choosing the primary alcohol. So this is the trick to remember. Okay,
Yeah, yes.
okay, see the second and third one. Second and third, just do that.
CH3, CH2, OH plus
Yes.
CH3, Br.
Very good. CH3. Yeah. Okay, you will choose the less number of carbon to prepare the haloalkane. Always. Now this third one.
CH3, CH2, CH2OH,
Yes. You will prepare the propanol plus.
CH3, CH2I,
Okay. Next thing is alkoxybenzene. If there is alkoxybenzene, so how you will break the bond? Okay, again this is an unsymmetrical type. Unsymmetrical है आपका ether. So when the alkoxybenzene is given, so it will always form the phenol and halol. In the case of alkyl, yeah, this one. In the case of both the sides, when both the sides alkyl group was attached, so there you will prepare the alcohol plus halol. But if one group is aryl group, okay, one group aryl hai and the second group is your alkyl group, so here you will prepare the phenol plus haloalkane. Phenol plus haloalkane if you have alkoxybenzene. आपको पता होना चाहिए what is alkoxybenzene, and if you see this type of a structure, this is oxygen linkage, and oxygen linkage one group, suppose this is a right side, on the right hand side alkyl group is there. R group means यहाँ पे alkyl group है. Alkyl group any CH3, C2H5 anything, and on the left side you can see this is a benzene ring. Okay, benzene ring. So this whole group, this OR group, इसे हम क्या कहते हैं? Alkoxy. Alkyl plus oxygen. Alkyl group plus oxygen. This is alkoxy, and this is your benzene. Alkoxybenzene. So that's the name. That's the name of ether, alkoxybenzene. Both the both the groups which is attached to the oxygen is different. One is alkyl group and the other is the aryl group. Benzene ring. So this is your alkoxybenzene. Alkoxybenzene will always form phenol and haloalkane. Okay, phenol बनाएगा and haloalkane बनाएगा. Why? Because the CO bond on phenyl has, again the question is which bond you will break. Because if we are just using the cleavage of CO bond, we are supposed to break the carbon and oxygen bond. Now the question is which bond you will break. Okay, again the आपको ये तो याद होना चाहिए this thing. Why we can't break this bond? Because this oxygen is involved in the resonance, right? Because it has a partial double bond character, so you can't. It is very difficult to break this bond. So this bond will break. You don't have any option. Okay, you have to cleave one CO bond, and you don't have any option in the alkoxybenzene because this oxygen is involved in the resonance. Okay, and it is very difficult to break this bond. So you have only one option. You have to break this oxygen and your carbon of the alkyl, this CO bond. Okay, now it's very simple. When you break this bond, so hydrogen के पास positive charge and this has negative charge. So hydrogen will be attached to this oxygen, okay, and it will form, hydrogen will be attached to this oxygen and it will form phenol. Plus, this R group, it will be attached to this iodine. It will form Ri. Okay, so when the alkoxybenzene is given, so it will always form phenol and haloalkane. And यहाँ भी कोई confusion की बात ही नहीं है because you have to break this alkyl group carbon and oxygen bond. Okay, because you can't break this bond because this oxygen is involved in the resonance and there is a partial double bond character which is very difficult to clear, Safrina.
Yes.
Okay. Okay, now let's do some questions. Suppose we have this. Here's oxygen. Now do this question. HBr. Okay, so write on the product. Which bond you will break?
The one with CH3 CH.
This bond you will cleave and you will attach the hydrogen to this oxygen and you will form phenol. इससे आप क्या करोगे? Phenol बनाओगे and this remaining group you will attach bromine. 1, 2, 3. On the second carbon you have to attach this 1, 2. Second carbon पे you have to attach the bromine. So that's the product. Okay, this is the case of alkoxybenzene. Now the thing, second is benzyl alkyl ether. Benzyl alkyl ether. So this was a benzene. See here, alkoxybenzene क्या था? This benzene rings are directly attached to oxygen. So this is the alkoxybenzene. When the alkoxy group is directly attached to the benzene. No, but what is benzyl group? So benzyl group is that. See, suppose we are just talking about a haloalkane, any haloalkane. So suppose this is a X halogen atom first, if it will be attached in the, what is benzylic group? You should know what is benzylic group. So benzylic group is that in which the functional group, any functional group like your, यहाँ पे हम बात करें ether की, we are just talking about the ether or any alcohol, OH group, hydroxyl group, your halogen group. Suppose this is the halogen group. So halogen group should be attached first to the sp3 hybridized carbon. sp3 से first attached होगा and this sp3 hybridized carbon is further attached to the benzene ring. To the benzene ring. So this is this type of arrangement आपको दिखे. So this is your benzyl group. This is your benzylic type of group and this carbon is known as benzylic carbon. Okay. So because here the functional group is O, this is the ether, right? So you can see this oxygen, this ether, first it is attached to the sp3 hybridized. sp3 hybridized आप कैसे देखते हो? Whenever there is all the single bond. Carbon के you can check over here the all the bonds are single. Carbon single bond है, so it is sp3 hybridized carbon. So carbon is sp3. If you will see see if carbon के बीच में only single bond, so hybridization is sp3. If you see one double bond, okay, suppose carbon and oxygen. So this is the CH3. This is acetone, propanone. So when we talk about the hybridization of this carbon and oxygen, this carbon, so you can check these two are the single bond, but one double bond is present. If one double bond is present, so the hybridization will become sp2. ये इसका hybridization क्या होगा? This is sp2 hybridized. Because two single bond तो present है, but one double bond is also present. So you will check one double bond. So hybridization will become sp2. If one 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 triple bond, carbon triple bond, if you see, so the hybridization will become sp. One triple bond or two double bond, both the same thing. If one triple bond, one carbon triple bond, or you can see two carbon double bond. So in both the cases, the hybridization will become sp. Suppose this carbon and nitrogen. carbon and nitrogen, and here there is some other. Okay, यहाँ पे कोई भी other group है like CH2, then CH. And here at the last CN, cyanide group is attached. So if I ask you what is the hybridization of this carbon, so what will be the hybridization, Safrina?
SP.
Yes, it's sp. Why it's sp? Because there is a one triple bond. Okay, one triple bond is present, so that's why the hybridization is s. Okay, and if you see this type of bond, carbon, carbon, two double bonds, two double bonds, so again the hybridization will become sp. Okay, तो अब तो इस पे डाउट होना नहीं चाहिए हाइब्रिडाइजेशन में. Clear?
If it has two double bonds, it's sp2, right?
Yeah. No, it's sp. Two
No.
double bond or two double bond or one triple bond. In both the cases, the hybridization will become sp, not sp2. Okay. So this is a benzylic type of group. Benzylic mein, it is very important that first it should be attached, the functional group should be attached to sp3 hybridized carbon. Then it is further attached to the benzene ring. So this is a benzyl alkyl ether. Benzyl alkyl ether. So oxygen, okay, this is your alkyl group. So it's alkyl. And this oxygen से ये कौन सा group है? This whole group is known as benzyl group. Benzene and benzene से जब CH2 group is attached, so it is your benzyl group. So that's why the name is benzyl alkyl ether. Benzyl alkyl ether. Now, so and yeah, one more thing. This benzylic group is very reactive. This suppose the tertiary carbocation and the benzylic carbocation. This benzylic carbocation is formed, and suppose if any tertiary carbocation is formed. So tertiary से भी ज़्यादा reactive होता है this benzylic carbocation. This benzylic group is very much reactive. Just remember that. It's very much reactive. Okay. So now the question is how we can, when you treat this benzyl alkyl ether with HI group, so what happens over here? Okay. So again, you know very well this bond, ये bond नहीं break हो सकता. This you are supposed to break the carbon and oxygen bond. Carbon and oxygen bond. So this is not a carbon and oxygen bond. आपको either this bond you can cleave or this bond. But you are supposed, because the CH2 is very much reactive, so you are supposed to break this bond. ये आप break करोगे. Okay, so this will become, this oxygen will acquire negative charge and this will acquire positive charge. So why it acquire positive charge? Because oxygen is more electronegative between this carbon and oxygen. So this will acquire partial positive negative charge and this carbon will acquire positive charge. Okay, so basically it will form carbocation. Okay, and benzylic carbocation is very much reactive and very stable. So that's why यहाँ से bond break होगा. This benzylic carbon and oxygen bond will cleave, not this bond. So in benzyl alkyl ether, you will cleave this benzylic carbon and oxygen bond, not this alkylic one. Okay, just keep this in your mind. Because this one is very much reactive. Benzylic carbocation is very much reactive. Okay, so this H plus hydrogen, it will goes to this oxygen and this iodine will goes to this iodine. Okay, and it will form CH2 and iodine plus this ROH, alcohol plus this. Clear? Okay, do this question. Write down in your notebook. Example number first and second.
With benzyl group. Uh,
You will basically cleave this one.
yeah.
Yeah? So you will
And
get, so this CH2 and I. CH2 and I, because CH2 will have the positive charge. So iodine has a negative charge, so it will attach to this carbon. So you can CH2 and iodine. CH2 and iodine. Plus the remaining group, this 1, 2 methyl group and oxygen, and it will, hydrogen will attach. So this is the product. Got it? Second one. Okay, there are two benzylic benzene ring. phenyl group. So you can also draw it like this. This is a benzene ring, CH2, oxygen, and here there is again phenyl as a drop. Okay, now how you will cleave this bond? Again, it is not possible to cleave this carbon or oxygen bond because it is involved in the resonance. So you can cleave this bond. And once you cleave this bond, hydrogen will attach to this. Basically, it will form phenol. ये phenol बना लेगा and this CH2 and iodine. CH2, iodine plus this will form phenol. So benzyl halide is formed as a reaction occurs via SN1 and benzyl carbocation is very stable and very reactive, right? So that's why you will prepare the benzyl halide in this type of reaction. Yeah, so when benzyl alkyl ether आप देखो, so it will form benzyl halide. Benzyl का halide बनाना है, right? And uh, because carbocation, benzyl carbocation is very reactive and stable. So that's why you have to cleave this carbon, benzylic carbon and oxygen bond. So just keep this in your mind. Next one, diaryl. Now you will tell me this. What will be the product in this case? How you will cleave the bond? Just think about it. It's a basic one. Diaryl ether. We are supposed to cleave the carbon and oxygen bond. Now just think about it. Is it possible to cleave this carbon and oxygen bond?
Mm.
No, because both the carbon is involved in the resonance with this oxygen, right? So both
Yeah.
have the partial double bond character. Both have the partial double bond character. So here the reaction will not, no reaction, right? So diaryl ether don't react with halogen acids. Don't react with halogen acids. Okay, now you can write down this reason. So this type of question can come in your exam. They will give you the diaryl ether and they will give you what will be the product in this case. So there will be no reaction, no product will be formed because diaryl ethers don't show this reaction, don't show the reaction with HX, halogen acids. Why? Because both carbon and oxygen bonds has partial double bond character due to the resonance, which is very difficult to break. The next reaction is electrophilic aromatic substitution reaction of anisole. Now the question is, what is anisole? Do you know what is anisole, Safrina? No?
Mm.
Okay, see, this is a benzene ring. And when O alkoxy group, when alkoxy group, what is alkoxy group? Alkyl group, CH3, methoxy group basically. This methyl group with this oxygen. When this methoxy group is attached to the benzene ring, so this is anisole. This molecule is known as anisole. Okay, benzene ring and benzene ring से attached क्या है? OCH3 group. So it is your anisole. Okay, so here is the oxygen linkage. Okay, and there is a aryl, alkyl group is side hai, and there is a aryl. Okay, so both, this is again an unsymmetrical type of ether. Okay, so oxygen linkage के right side CH3 group होता है, and on the left side there is a benzene ring. So this is a anisole. Okay, this oxygen has a lone pair. So this anisole, this oxygen has a lone pair, right? And this OCH3 group, because oxygen के पास lone pair है, so what it does, it basically, it donates its electron. It's an electron donating group. It's an electron donating group. It donates its electron to the ring, to the benzene ring. And due to that, the electron density increases in the benzene ring. Due to that, electron density increases in the benzene ring. So basically, ये होता है electron donating group. Okay, it just donates the electron to the ring. So, and now the question is, what is electrophilic? What do you mean by electrophiles? Just like a nucleophilic substitution reaction हम पढ़ रहे थे. तो nucleophiles क्या होता था? They are electron rich. Okay, nucleo, just I always remember to break the word को break करके just try to understand. So nucleophile, nucleus and phile means loving, nucleus loving, and nucleus loving कौन होते हैं? Which are electron rich. Okay, which are electron rich, जिनके पास electrons होते हैं, they just attract the nucleus because nucleus is positively charged because it has protons in it, right? So always remember, unlike charges attract each other. Okay, so opposite charges attract each other. So nucleophiles, nucleus loving है, तो it means it has a electron rich. It is electron rich. इसके पास electrons ज़्यादा होंगे. So that's why वो nucleus को attract करते. So similarly here, electrophile, electron loving. इलेक्ट्रॉन लविंग कब होंगे? विच हैज, दिस इज बेसिकली कटायंस होते हैं, दे हैव अ इलेक्ट्रॉन डेफिशिएंसी, इलेक्ट्रॉन्स की कमी होती है इनके पास, सो दैट्स व्हाई दे लव इलेक्ट्रॉन्स, दे लव इलेक्ट्रॉन्स. सो इलेक्ट्रोफाइल्स क्या होते हैं? The electrophilic aromatic substitution reaction means it involves electrophiles, and electrophiles means electro means electron. Okay, electron loving. So they are basically electron deficient होते हैं. They are electron deficient and basically they are cations. Cations क्या होते हैं? Positively charged. They are positively charged because they lack electrons, and the representation of electron is capital E, and इस पे हम positive charge ऐसे show करते हैं. So this is the electrophile. This is the electrophile. Electrophiles are electron loving. Okay, and how they love electron? Because they have deficiency of electron, they lack electrons, so that's why they are electron loving. And basically ये cations होते हैं, इनके charge क्या होते हैं? Positive charge होते हैं. Positive charge means there is a lack of electron. Okay, so electrophilic aromatic substitution of anisole. So what is electrophilic substitution? Means electrophile will come and replace basically some atom. Okay, one atom or the group of atom will be replaced by some electrophile. So that's the electrophilic aromatic substitution of anisole. Okay, so see this alkoxy group is an activating group. This alkoxy group जो होता है, this is the methoxy CH3O group. ये क्या करता है? ये activate कर देता है हमारे benzene ring को. How it activates? Because it is electron donating group. It has a lone pair. The oxygen has a lone pair. It donates its lone pair to the ring, which increase the electron density of the benzene ring. Electron density को क्या करता है? Increase कर देता है. Okay, and once you draw the resonating structure, so you will find that the electron density increases at ortho and para position. At ortho and para position. So corresponding to this OCH3, what is ortho position? This is ortho, this is your meta, this is ortho, meta, this is your para, this is again your meta, this is your ortho, right? So ये क्या करता है? Due to the alkoxy group, due to the electron donating group basically activate the, it is an activating group. ये क्या करता है? Activate कर देता है benzene ring. Benzene ring activate हो जाता है at, and the electron density increases at the ortho or para position. So ortho, on the ortho as well as on the para position, the electron density increases. Okay, and because when the electrophile, suppose any electrophile will come, because electrophile is electron loving, वो कहाँ attack करेगा? Where the electron density is more, where the electron density is more, वहां पे वो attack करेगा electrophile, right? Because electrophile are electron deficient. They are electron deficient. They love electron. They attract the electron. So when the electrophile will come, they will they will attach on the ortho as well as on the para position, because in the anisole, this OCH3 group is the activating group. It increases the electron density on the ortho as well as on the para position. Ortho or para position for the electron density is more. Okay, and the electrophile will attack on the ortho and para position. Why? Because electron density वहाँ पे ज़्यादा है. Okay, and you know very well this electrophile is cation, right? It's love electron. तो वो कहाँ पे attack करेगा? Where the electron density is high. Okay, means the electrophilic aromatic substitution of anisole will give you the ortho and para directing product. Para, ortho and para product you will give. Is it clear, Safrina? So when you do any reaction, any electrophilic aromatic substitution reaction, whether it's nitration, whether it's your Friedel-Crafts alkylation, acylation, कोई भी reaction आप कराओगे, so you will get the ortho as well as the para product. And always remember, the para product is a major product. Para product is a major product. Why it is major product? We will discuss it soon. Okay, so see. Yeah, we will discuss some reactions of the anisole. What is this? This is your anisole. This is your anisole. When you do the halogenation reaction, so halogenation reaction आप कराओगे. So here the halogen is basically the electrophile. Bromine plus. This is the electrophile. Halogen will act as an electrophile. Okay, and you know very well this OCH3 group is an activating group, and due to the presence of this activating group, the electron density increases on ortho. Okay, these two are the ortho position and this is the para position. So here the electron density increases. So you will form, yeah. What happens over here? Bromine, जब आप halogenation कराते हो, so you will get a OCH3 group over here. Okay, and this bromine, this Br plus is the electrophile over here. So electrophile will form this ortho product plus your para product, OCH3, and para position पे आप attach करा दो bromine. So these two products, OCH3 as it is. Okay, what you are supposed to do, आपको electrophilic substitution reaction कराना, right? So each and every carbon has one hydrogen. Okay, in the benzene ring, each and every carbon has one hydrogen. So one hydrogen is replaced by this electrophile. Okay, and why it attacks on the ortho and para position only, not on the meta position? आपको meta product नहीं मिलेगा. Why? Because electron density is increased on the ortho as well as on the para position, not on the meta position, right? So, and you can see this one position and the second position. यहाँ पे ज़्यादा hindrance होगा. There will be more hindrance, right? So due to that, this is your minor product. The ortho bromo anisole is the minor product, but this para जो बनेगा, this para one, this is your major product. This is your major product. Always remember in the electrophilic substitution reaction, two products is being formed, ortho product and the para product. And para one will be the major product. Why it is major? Because there is less hindrance. यहाँ पे देखो bromine यहाँ पे इस position पे and the other group OCH3 group is here. Okay, there is more distance. Distance यहाँ पे ज़्यादा in between these two groups. But here the distance is less. Okay, the adjacent carbon पे bromine is attached. So due to that, there will be hindrance between the bromine and this OCH3 group. So due to the steric hindrance, this will be the minor product. This is your minor product and this is your major product. Clear, Safrina?
Yes.
Similarly, if you do the nitration, if you do the Friedel-Crafts alkylation, acetylation, so you will get the same thing, ortho and para. Okay, but you should know in the nitration, in the Friedel-Crafts alkylation, what is the electrophile in this case. Electrophile क्या है? So in the nitration, you use concentrated HNO3 plus concentrated H2SO4. Okay, whenever when you do the nitration, you will use this combination, concentrated nitric acid plus concentrated sulfuric acid. Okay, and here what will be the nucleophile? So the nucleophile in the nitration is NO2, NO2 plus. This is the nucleophile. Sorry, electrophile. What I'm saying, because we are just doing the electrophilic substitution, not nucleophilic. So this is the electrophile over here.